Hello everyone. I'd like for us to take a look at this graph of f of x. And you notice I've done a lot of labeling. Your function is decreasing. Again, if you're on the roller coaster ride, you're coming down. You get to a point where your function is constant, neither increasing nor decreasing. And then your function starts increasing in here, all the way up to where your function is constant again, and then your function decreases. Okay, so this is considered to be a local minimum. It's the lowest point in this region. And this is a local maximum. Okay, so you'll notice that the transition from decreasing to increasing is right here at the local minimum, and the transition from increasing to decreasing is right here at your local maximum. So let's see if we can write that in terms of the slopes of the tangent line. So we said that if f was decreasing, then the slope of the tangent line would be negative. That's what we said on the chart. And if we were to sketch that out, you just pick any point on your function where your function is decreasing, and you can draw in your tangent line. You should see that the slope of this line is negative. Okay, so then we get here where we see a transition from your function decreasing to increasing. And at this specific point where this transition occurs right here, we could say that f prime equals 0, right? So you had a negative slope, and then you get to your point of transition where your derivative is equal to 0, right? And then in here, your function is increasing, and you can see that just pick one point. You don't have to do them all. And you can see that the slope of these tangent lines are all positive, right? So you went from a negative slope where your function was decreasing to a 0 slope where your function is constant, to a positive slope where your function is increasing. And then we get over here, we see another transition, right? And right here where you have a local maximum, you see that again, your derivative is equal to 0. Okay, in both of these spots, you should have 0 slope, right? Your max and your min, that's where you're transitioning from increasing to decreasing. Okay, now I'm telling you things for a reason. So if you pick any point, it really doesn't matter where you go. Right? So if I draw that in, you could see this relationship occurring again, that you have the slope of your tangent line being negative. So then the question is, how does that play out in a word problem? Okay, I cannot emphasize enough that your transitions from decreasing to increasing or from increasing to decreasing are happening both at your max and your min, and in both of those cases, your derivative is equal to 0. All right, so I keep saying that because that is going to be a key to finding what's called your critical points. So your critical points are your max min points, because those are the points of transition. All right, so in your notes, you have a problem, and I did the problem in its entirety. So you guys can take a look at that and follow along. I'm going to do that now so you can see what I would do in a typical class. Let me show you the problem of which I speak. Again, this has been worked out in its entirety. So I'm right here. Okay, so we start off with f of x equals 3x to the 4th power minus 4x cubed minus 12x squared plus 3. Now, your goal, or the task that you're going to be given, is to sketch this. So you're probably saying, Dr. T, I could just throw that into my calculator and see what it looks like. But I'm going to say, use your first derivative in order to tell me what this function looks like. You won't be able to use the original function. Now I'm going to go back to this because I'll notice that I have critical points occurring at those spots where my derivative is equal to 0. So I'm going to look for those. All right, so here I go. I'm going to take my derivative and set my derivative equal to 0 in the hopes that a max or a min will pop up. Something else might pop up. But at the max and the min, we would hope that the derivative is equal to 0. So here we go, f prime of x. Here's f of x. So if I want to go to f prime of x, I just take the derivative. This is power rule, 12x cubed. That's the derivative of this one. Minus 12x squared minus 24x plus 0. All right, so that's the first part. that takes care of you taking your derivative. The second part, and I'll put a 1 there because that is step 1. The second part is to set your derivative equal to 0. What do we get? 12x cubed minus 12x squared minus 24x. Set this equal to 0. Again, I cannot emphasize enough, we're hoping that a max or a min pops up when we do this process. All right, so there are a variety of ways you can do this. You can plug this function into your calculator, do second calc number 2 and look for roots because you do have a function that is equal to 0. Or you can try to do it by hand. I'm going to pull out a 12 and also pull out an x because it seems to be common in each one of these terms. So let's see, x squared minus x minus 2 is equal to 0. All right, so some of you are very skilled at factoring. If you don't know how to factor, your book gives some resources at the back of it, and of course you can see a YouTube video as well. So 12x, and I believe this is x minus 2 times x plus 1 is equal to 0. Now the reason I like to factor is because I can start thinking about what x could be. All right, so I need to go off on a brief aside because I need you to take something into consideration. All right, so if you have, let me move this out of the way for a minute. If you have x times 2 times 3 is equal to 0, you would expect x to equal 0. If you had 5 times x times 49 equals 0, you would expect x to equal 0, right? Even if x is in the middle term. If you had 18 times 74 times x is equal to 0, here you would expect x to equal 0. Okay, so the point that I'm trying to make is that you have one of your terms has to be 0 in order for the product to equal 0, right? When you multiply them together, if it equals 0, then one of them has to equal 0. So we're going to use that idea in what we show next. So going here, we have 3 things multiplied by each other that equal 0. One of them has to be equal 0. So either 12x equals 0, right? So if you divide by 12, this gives you that x equals 0. There's one possibility. Or x minus 2 equals 0. Add 2, make sure you're showing the work. X equals 2. Another possibility. Or this third one has to equal 0. X plus 1 equals 0. Minus 1, x equals negative 1. All right, so let's go back and see what we were trying to do. We looked at where the derivative was equal to 0, which is where our max-min should pop up. Why? I'm going to go back to this picture. Look, that's where you get 0 slope. Your minimum, you get 0 slope. And your maximum, you get 0 slope, right? So this stuff is not random. Sorry about that. So we would expect these to be max, min, or a question mark, right? It doesn't have to be a max or a min, but our expectation is that it would be a max or a min.